All right, so we are on section 6.3. Everybody ready? Yes? Okay. All right, so here we go. We are learning about multiplication property of equality first. And it says when you multiply each side of an equation by the same non-zero number, the two sides remain equal. This sounds very similar to adding and subtracting, right? All right, so I'm going to give you the first problem we're going to solve. So everyone write key idea. You're writing x over 4 equals 2. Please make sure your 4s look like 4s and not y's. I see a lot of people writing y's, and I know it's supposed to be a 4. Okay, so we are doing exactly what we did in our adding and subtracting. So what's our goal? What's our goal, Conrad?
Get the variable.
You got it. So everything here, all the rules apply. A variable needs to be alone. Okay. So is the variable alone? No. What's in its way? The 4, right? The 4 is what is in its way. With division and multiplication, we don't have to worry about negative and positives right now. All right? That was only with adding and subtracting. All right? So, what operation do you see? Peter? Division. What told you division? Nina? The fraction line. Okay? That told us division. So, what is the inverse operation of division? Ashley? Multiplication. So, this is what I want you to do. You're going to write parentheses. You're going to use parentheses for multiplication. All right, I'm going to say for multiply because it's just easier to write. All right, so you're going to use parentheses for multiplication. All right, so we are going to multiply to one side or both sides? Both sides. Make sure they look like parentheses. I like parentheses because it tells you what you're multiplying by, okay, what you're multiplying to. All right, so what number is in the way?
4.
The 4. So what do you think we need to multiply to both sides by? No. What did we just say? What's in the way of x being alone? Yeah. The 4. So we need to multiply both sides by 4. So you can write 4, or you can write 4 over 1. Okay? Either way, it's the same thing. Okay? I'll leave 4 over 1 up, but it means the same thing. And I'm going to show you up here. This x over 4 equals 2, you may sometimes see it like this. It means the same thing. Okay? Because think of what's in front of x. What's in front of x when it's by itself?
0.
No.
1.
A 1. Very good. Okay, so it's a 1. So this means the same thing. So you're really doing 4 over 1 times what? What are we really multiplying by? What's up here? This means the same thing as this. Conrad.
Multiplying by.
Here's your 4 over 1. This represents this. So what am I really multiplying by? 1/4. So let's look at that. What's 4 times 1? And what's 1 times 4? Anyone? 1 times 4? 4. Good. Which gives you what? 1. Very good. So this means that these are crossed off. All right. So if 1 is down here, think about it. 8 over 1 equals what? 8. 12 over 1 equals what? So what do you think x over 1 equals? X. Very good. So that means x is by itself. Okay? What we do to one side, you have to do to the other. So what are we going to multiply by? 4. And you do not have to write the 4 over 1. Okay? Because 4 over 1 is the same as 4. Does that make sense? If you understand this, you can erase this 4, this over 1, and you can just do it like this. I'm okay with that. Okay? All right, so what am I going to write down here? Peter.
4.
Oh. What's left on the left-hand side? Ooh, you forgot something over here. What did I do on this side? Something's missing. What did you do one side, you do the other. There you go. All right, so who can help me out? Nina.
When we do x equals 8.
Ah, there you go. All right, because x is the only one left right here. We crossed off our 4s. And what's 2 times 4? 8. All right, so let's check our answers. Let's check our work. I'm hoping to hear more participation, guys. They need to make sure you're understanding this. All right, so here's your problem. So what am I going to do to help me check my work? Sam?
You put the 8 over the 4.
Yes, so you're going to substitute, right? So 8 over 4 equals 2. Oh, that does not look like a 4. And then what's 8 divided by 4? So 2 equals 2. Is that true?
Yes.
Yes. All right, so does that mean 8x equals 8 is my solution?
Yes.
Yes. Is everybody good? Everyone's all right? Okay, so let's go. I'm going to show you the next key idea. They are just trying to show you the reciprocal. So remember on my first key idea, I showed you this. That 4 over 1 times 1 over 4, what does it equal? 1, right? So we're going to do it here. All they're saying is, if it's 8 over 1, what's the reciprocal? 1 over 8. So let's try this one. What if it's 1 over 9? What's the reciprocal? 9 over 1, and then what does that equal? What is it? 9 over? No, not 9 over 1. 9 over 9, which equals? What does it equal? 1. Good. What if it's 1 over 150? What's the reciprocal? 150 over 1, and then what does that equal? Right, 150 over 150, which equals? 1. Good. So now they're giving you this with a variable. So if it's 1 over n, what's the reciprocal? N over 1, which is? Nope, well before that. N over n, which equals? 1. Okay? Is everyone understanding this? Okay. All right, we're going to try some problems. So you're going to write example 1, problem A. All right, so you're going to write W over 4 equals 12. This is pretty much the exact same problem as we just did. All right, so what's our goal? What's our goal? Who's that? Amy, got it. You want W by itself. Is W by itself? What's in its place?
4.
What operation do you say?
Division.
Okay, what's the inverse?
Multiplication.
How do we show multiplication?
Parentheses.
Oh, I love it. Okay, so we're going to put parentheses on one side or both sides?
Both sides.
Good. Okay, what are we multiplying to both sides? Remember, you want the variable to be alone. You have to remember that statement. Conrad?
You'll be multiplying 4 each side.
Yes, you want to multiply by 4 to both sides. Can you do 4 over 1? Yes. Okay, you don't have to. Okay, now, I know in the previous problem, I did all this work doing the 4 over 1 to show you the 1. You do not have to do that. You should now know that these just cross out. Does that make sense? Okay. You know that this now represents just W, correct? Yes or no?
Yes.
Okay. But We do have to do the other side. So who thinks they can tell me what my next row is going to be? Sam. W equals 48. Do you agree?
Yes.
All right, let's check our work to make sure. All right, so W over 4 equals 12. What am I substituting my W for? Ashlyn? Yeah, so I'm going to write 48 equals 48 over 4 equals 12. All right, what's 48 divided by 4? Everybody. And then 12 equals, so is this true?
Yes.
So what does that tell me about W equals 48? It's the solution. Very good. Okay. Is everybody good with A? Okay. B. All right. There are a couple of ways to do B, and I'm going to do both of them. I'm going to write 2/7 x equals 6. Okay. What operation do you see here? What operation? Ashlyn? It's not division. You're looking at 2/7 as a fraction right now. And it's next to the variable. Luke, that's a 6. Yeah, Luke. Say it again. It's multiplication. It's kind of funny that it's in this slide because we're really wanting to do the inverse being multiplication. And you really are, so I want you to kind of remember that, okay? Right there is multiplication. So what inverse is of multiplication? What's the inverse? Everybody. Division. How do we show division? How do we show division? Yes, so I need you to write down, you are not using that division sign. Cross that off. You are using a fraction line. All right, so we are going to have to make sure our line is a lot longer than this line. Does everyone understand that? What are we dividing by to both sides? Remember, you want your variable to be alone. That ends. 2/7. Very good. Okay. I need you to really think about this because technically you should be able to multiply this. Are you ready? You are doing 2/7 divided by 2/7. Peter. Yes. So really, are we dividing? No. What are we doing? We are multiplying. So we're doing 2/7 times what? Yes, which gives you what? 14 over 14 if you don't cross cancel, which gives you what? 1. So now be careful how you cross off. You're going to cross off one at a time because fraction's a little harder. Okay? Then when you come over here, you're doing 6 divided by 2/7. But what are you really doing? Mina? Yeah, so you're doing 6 over 1, then what? No, not 2/7. Right. Okay. Now, this is where the or comes into play. Are you ready? Because you do not have to show the fraction line and you don't have to divide by 2/7. We can take the original problem and we can skip the whole process of dividing by 2/7. And we can multiply. We could go right to multiplying. But what would I need to multiply to both sides? Think about it. What would I need to multiply to both sides? Dylan.
As a mixed number, it would be 3 1/2, but as an improper fraction, it is 7 halves.
You would be multiplying by the reciprocal. Okay, so we're not going to change it to a mixed number. Okay, but yes, you are going to do 7 over 2. So I would write somewhere that when you have a fraction next to a variable, you want to multiply by the reciprocal. Okay? So when you have a fraction next to a variable, you want to multiply by the reciprocal. And then that cuts corners. You guys like cutting corners. Okay? Now, if you feel more comfortable doing it this way, can you? Yes. All right? But you will see that this way is a little bit easier and less work to do. Okay? Now, 7/2 times 2/7, we did it up here. So watch how I cross them off. One at a time. Okay? One at a time. Now here is 6 times 7/2. So can I cross cancel?
Yes.
All right, so what does a 2 become?
1.
What does a 6 become?
3.
And what's 3 times 7?
21.
Over?
1.
Good job. So then what is my final answer? Emily? X equals 21. All right, I had to show you both methods. All right, so some of you may like it this way. Some of you may like it this way. This is the way you really want to do it. Okay, where you're multiplying by the reciprocal. Okay, but if you want to do it with the dividing, you can. Are there any questions on this? Sam? You can check. I don't have any room to check it, but when you check it, you would do 2/7 times 21. Okay? And then see if you get 6. You should. Okay? All right, now, I want to go over a few of the triads before we go to example 2, and then we're all done. So, look at number 2. And if you want to, write down number 2 so that you know about this problem. So when you get to it, you'll know what to do. Do you see that it looks a little different? Do you see that the variables on the same number, like line with the numerator of 2? Okay? So take a look at what we did here. Do you see how the fraction is separated from the variable? Yes? You can separate this. You're allowed to. So do you see a fraction? And then do you see a variable? Can anyone tell me what I'm going to write? It's going to be 14 equals, Peter?
Y and 2 this.
Say the fraction first.
2 this. Y.
Yep, just like this. Does that look a little bit easier now? All right, and then what would I be doing the reciprocal of? What would I be multiplying by? 5/2. Excellent. If I wanted to divide, what would I divide by? I should hear everybody. What should I be dividing by here? 2/5, or multiply by 5/2. What am I doing here? What am I multiplying by? Sam? 8. Okay? Is everyone seeing this? All right, so let's do, there's one more, there's this one. This looks so tricky. They're trying to trick you. They shouldn't, this should not trick you. What does a division sign mean? What does it mean? No, I know that, but what also can it represent? Sam? A fraction line. So how can I write this as a fraction? Luke? Say it again, I'm sorry. So 3z/2 equals 9. That's perfect. And then what did I just tell you when you have a number with a variable? What can you do? Owen?
Put the z on the side.
Yeah, so what do you think?
3/2z.
Yes. So don't let this division sign trick you. Make it a fraction. Okay? Everybody good here? All right. How many of you, your minds are going, uh-oh. Don't worry, it gets really easy right now. Now it's easy. Are you ready? Key idea. You're going to like this last 2. You're going to go, oh, thank goodness. Those are probably the trickier ones of them. Okay, when you have to do the reciprocal. All right, so for this key idea, we're going to work with 4x equals 32. It says when you divide each side of an equation by the same non-zero number, the 2 sides remain equal. Okay, ask the same question. What's the goal? Ashley. You want the variable to be alone. Is the variable alone? No. What's in its way? They like to use the number 4. I'm just coming to that conclusion. Right, 4 is in the way. What operation do you see? Multiplication. Why? Where's the multiplication? How do you know it's multiplication? Come on.
When a variable is next to another, it equals
Excellent. When a variable is next to a number, it needs multiplication. Okay. What's the inverse operation? Everybody. Good. How do I show division? Who remembers? Amy. Fraction line. So remember, you're going to put it under the 4x, under the 32. What are we dividing by? So both sides. What are we going to divide by? 4. Okay. What's 4 divided by 4?
1.
So cross those off. What's 32 divided by 4?
8.
So what am I going to write? And you're done. Those are your easy ones. That's it. I know. I know. We talk about it all the time. It's so, example 1 is the hardest of them all. Okay? Example 2, you're going to go. Okay? Now, check your work. Now that I have some work. Alright? So 4x equals 32. Okay, so what am I going to substitute x for? Everybody. 8. So I'm going to do 4 times 8 equals
32.
Alright, so what's 4 times 8?
32.
And we're going to drag this down. 32 equals 32. Very good. So, is this true? Yes, it is. Very good. Alright, so we are good. Alright, this example and we're done. And then I'm going to have you guys do all the problems. We're going to work together. Alright, so you're going to write 65 equals 5b. Ready? What's your goal? You want your variable to be alone. What's in the way? 5. What operation do you see? Multiplication. What's the inverse?
Division.
How do you show division?
Fraction.
Alright, what am I dividing to both sides? Good. Oh, I'm doing it to the wrong problem. Well, it's the same problem, but. Alright, what's 5 divided by 5?
1.
Cross those off. What's 65 divided by 5? Good. So what am I going to write?
15. B equals 13.
Careful. Hey, I'm hearing 15 and 13. What is it?
15.
Wait. Hold on. I'm hearing 2 different answers. I'm hearing that 65 divided by 5 is 15. I'm also hearing 65 divided by 5 is 13. Which one is it?
13.
Okay. So now tell me what the equation is.
13 equals 8.
Okay. So I'm hearing people say B equals 13.
No.
And I'm hearing 13 equals B.
13.
Yes. Because why?
65 B is at the first number.
Right. The B is on the right-hand side. Very good. So 13 equals B. All right, let's check. Especially since a lot of you said 15. So let's try that. 65, and then we write 65 equals 5 times 15. Let's see what people are saying 5 times 15. What's 5 times 15?
That's 85.
What is it? Is it 85?
75.
75. What would I have found out? I would have found out this is false. So what would that have told me? That my variable was wrong and that it's not 15, it would be 13. Does that make sense? All right. Does anyone have any questions? Luke?
Why would you cross out the 5 and 5? Because they're not like
Because you want those 5s gone because B is now alone. Right? Because 5 divided by 5 is 1. Right? So when you have B by itself, right? What did I read here? Yeah, that's a big. When you have B by itself, what's in front that's invisible? So 1. Okay, does that make sense? Okay, good question. All right, everybody good? That's you. Is everybody okay? Are you sure? All right, I'm gonna stop the video and then you guys are gonna do your try